Brand new topic. Okay, now standard form numbers are like that one in green at the bottom of the screen. Okay, now in real life, these are used when numbers are massive. So you've got loads and loads of noughts, and if you were typing it or writing it down, it'd be very easy to forget to write some of the noughts. So for very big numbers, but it also something, very small numbers, so something like 0.00000000643. It's good to then use this standard form because, again, if you were writing that number down, which has got buckets of noughts after the decimal point, it's very easy to make mistakes. So these are used a lot in real life for hugely big numbers and very small numbers. Okay. Now, the way a standard form number works, and in a way, it would be the following lessons where this becomes particularly important. It's not crucial today, but the way standard form works, you first of all have this number here, which is always between 1 and 10. Okay, it could be a decimal, but it might not be. So it could be a whole number. But the first bit is always between 1 and 10. You then have written down times 10 to the something as the second part. And then thirdly, you have a power. Now, it's going to be worth getting used to this straight away. If this power is positive, then we're talking about very big numbers. But if this power was negative, then we're talking about very small numbers. Okay. Now, what we're going to concentrate on today, and what the Hegarty exercise that you'll be doing shortly is all about, is you're given a standard form number like this, and your job is to convert it back into a normal everyday number. Okay, so that's the process that we're going to have to try and figure out. Now, what I've done with my slides, excuse me while I just take off my keyboard. I'm hoping I might be able to do these live so I can actually write them out rather than just point to ones I've done already. So it depends on how well my internet's working. So I've got two options. So this is the page where I'm hoping I'm going to be actually able to do it live, but then I've got a backup page on the next page if it's just not working. So here we go. So this will be the thought process. I want to convert 6.21 times 10 to the 5. Now, my thought process is that is a positive number, so I'm going to be turning it into something really big. So as a working, what I go and do, I go and write down my 6.21. And because I'm going to be turning it into a really big number, just go and put loads of zeros down as a workings. It doesn't matter how many you put down, just put loads. Okay, and I've put them to the right because I know I've got to end up with a really big number. Now, the next step, you've just got to think of the decimal point starting where it is, and you've got to bunny hop it along 5 jumps. It's got to do 5 jumps because of the power of 5. So literally as a side working, do this. 1, 2, 3, 4, 5. So my decimal point is going to have to end up where that arrow is pointing. Okay, so that's my working. So I can go and see that I need to have 3 zeros. I need to have 3 zeros in my answer. Those 3 zeros there. Okay, I've got the three zeros. So that's my working. So my actual final answer is going to be 6, 2, 1, and then 3 zeros. Now, I don't need to go and put the decimal point in, but the decimal point would be there on the end, but I don't need to put it in. But so what I did, so just to go over that again, I saw it was a positive power, so it's going to be a big number I need to convert it into. So therefore, I put lots of zeros to the right, and I then bunny hop the decimal point along 5 because it was a power of 5. So let's take the next one as an example. Okay, so this second one here, again, it's a positive power 7. So I know it's going to be a big number. So I write my 3.6 down, and I put lots of zeros down. Really, it doesn't matter, just loads. It's just giving me something to bunny hop over. And I've got to bunny hop the decimal point 7 jumps. So 1, 2, 3, 4, 5, 6, 7. So the decimal point's going to end up there. So I then go and count up how many zeros my answer is going to have. And it's going to have all, whoops, that's a bad choice of colour, never mind. It's going to have all of those zeros there. So that's 1, 2, 3, 4, 5, 6 zeros are going to be part of my answer. So 3, 6, and then 6 zeros. 1, 2, 3, 4, 5, 6. So that's my final answer. Now, of course, I can then go and put in some commas to make it a bit more manageable. So working from the right, comma, comma, but you don't have to. So going back to the first one I did, I could have put a comma in there. I don't think I'll bother doing question number 2. I think you can see what's going on. You would obviously question number. Oh, I'll tell you what. Might as well do it. Why didn't I do it? So 7. Copy out the number 72152. Put in some more zeros. And on this occasion, I've got to do 6 bunny hops. So bunny hops, so it's actual jumps. The decimal point 1, 2, 3, 4, 5, 6. So it's going to finish there. So on this occasion, I've got 2 zeros on the end of my answer. So my final answer is 7, 2, 1, 5, 2, and a couple of zeros. Okay, so if I was to put the commas in there, I've got 7,215,200. So all of these on this slide were big numbers. Okay. Now, it may be that you've got small numbers. And you'll see with all of these here, I've now got a negative power. So all of these are going to end up being small numbers, tiny numbers. So because it's going to be a tiny number, go and get ready by putting lots of zeros to the left-hand side, because you're going to be jumping in the opposite direction. Then write in your 2.16. And the same idea, but we're just bunny hopping in the opposite direction. So I'm now going to have to do 5 bunny hops to the left. So let's change the color for the hops. So 1, 2, 3, 4, 5. That's where my decimal point has got to end up. Okay. Now you can see that I've got 1, 2, 3, 4 numbers after the decimal point. 4 zeros after the decimal point. 1, 2, 3, 4, and then my 216. So that is my tiny number that I end up with. Now, it's just a convention, and I'm not exactly sure why, but we don't ever write a number like that. We always just put in another 0 before the decimal point, just to make it look nicer. So you don't start a number with a decimal point, you put a 0 in front of it. So let's go and practice question number 1. I can see that it's going to be a small number because I've got a negative power. So go and put lots of zeros to the left. It's only a working, so you can put in as many as you want. Copy out the number in the question, 3.9265. And on this occasion, I'm going to have to bunny hop 6 times. So 1, 2, 3, 4, 5, 6. So this answer is going to have 1, 2, 3, 4, 5 zeros after the decimal point. 1, 2, 3, 4, 5. Then you copy out all the other numbers. Don't leave any of the numbers out. Always include all the numbers that are in the question. And as I said a minute ago, by convention, we just go and put a 0 in front of it. Obviously, it doesn't change the size of the number. The decimal point isn't moving. So that's how we do it. I think I'll leave question 3 because I'm running out of room. So when this lesson is over, I would like you please to go and do a Hegarty exercise. Now, I noticed in the questions that sometimes the questions that Hegarty gives look like these two on the slide. So I just want to go and cover these. If you've got 8.6 times 10 to the 1, well, times 10 to the 1 just means you bunny hop along one place, because basically you're just multiplying 8.6 by 10, because 10 to the 1 is 10. So if you've got something like 8.6 times 10 to the 1, just multiply it by 10 to get 86. Now, also, he's occasionally throwing in this nasty one in red, 8.6 times 10 to the 0. Now, anything to the power of 0 equals 1. So this bit here just means that you're multiplying by 1. So 8.6 multiplied by 1 is just 8.6. So if you find in the Hegarty maths exercise you get any questions where you've got a number times 10 to the power of 0, your final answer is just that number. Okay, so 7 times 10 to the 0 is just 7. 25 times 10 to the 0 is just 25. So whenever you've got times 10 to the 0, the number doesn't change because times 10 to the 0 means 1. Okay, so here is the Hegarty maths exercise that I've set you up to do. I want you to do Hegarty maths exercise 1, 2, 3. Now I have set it up on Hegarty all ready for you to go, but if you go onto Hegarty and you find that it's not showing, it's just because Hegarty's been very slow to upload them at the moment. So just go into the search box on Hegarty, pop in number 1, 2, 3 into the search, and it will prompt you with standard form to ordinary. Click on that and just go and watch the video if you like. If you want to hear someone else explaining how to do it, he might explain it a different way. But what's important is that you go and have a go at the quiz and generate a percentage. I can see that percentage and I'll copy that across to my mark book. Okay, so let me just show you. So this is I've got 2 or 3 examples of the ones that he's done. So write in ordinary form 7.82 times 10 to the 5. That's a big number. So I went and put loads of zeros to the right hand side and I jumped 5 times, giving me the answer 482,000. All right. So some of the questions that he'll ask you to do are going to be converting to big numbers, like number 4 there. Or it could be like this question 6, because it's times 10 to the minus 3, it's going to be a small number we ended up to. So I've popped the zeros to the left-hand side, jumped 3 hops across to the left. So my final answer was a small number. It was 0.00486. Now, you've probably found on Hegarty that the questions progressively get harder. So this is like the sort of medium level questions. But I've noticed that number 9 or number 10 are quite a bit of work. So don't overly worry if you get 9 or 10 wrong. But what you've got to do with these, you've got to put these 4 numbers in order. So what you've got to do, you've got to go and work them all out. You've got to turn all of them into normal numbers, and that will then allow you to compare them. So I've gone and worked out that this first one, 790 times 10 to the minus 3, was actually 0.79. When I've worked out the second one, it's 7.9. Obviously, 79 is just unchanged. And 7.9 times 10 to the 2 is 790. So I can then easily see, going from smallest to biggest, it's 1, 2, 3, 4. So my final answer would be 1, 2, 3, 4. So those are tricky. So I think you'll find the exercise finishes off with a couple of those. But by then you would already hopefully have got 8 out of 10. So that's already a good mark, even if you struggle on those ones right at the end. So thanks for listening, guys. I'm going to finish the video in a second. As always, it will automatically upload to Teams. So you can just go and watch this video again in posts if you're still a bit unclear or if you've missed the lesson. And as you also know, all of these I'm uploading onto YouTube. So if you just go and Google Maths by Mr. Withers, you'll see that I've got all the remote learning playlists right at the beginning, and obviously ours is the third form one. Okay, guys, well, thanks for listening. Have a lovely long weekend, with it being a bank holiday weekend. I'm just going to go and stop the video, stop recording, and then I will leave the chat.